Now let's see vectors in plane in two-dimensional. So just now we know our position vector is in terms of v. So let's write our v as AB, where A is the first part and B is the second part. So actually we can rewrite this in terms of AI plus BJ. So what is A? A is the horizontal component of the graph and B is the vertical component of the graph. Why did I say this? Because if you draw an axis of X and Y, X here represent your I part, which is the horizontal component, and then Y here is representing your vertical component. Okay, so since we have the point AB, let's write here. This point here is AB. Then let's do a line here, starting from the origin towards the point of V equal to AB. So we can write here the horizontal component here as the distance of A and the vertical component here as the distance of B. Now let's see this line here. This is your magnitude. Okay, we call this magnitude of V. So let's calculate magnitude of V. This is just Pythagorean Theorem. You can see this clearly. This is A, this is B. So this is the hypotenuse. So magnitude V is equal to square root A squared plus B squared. Now let's see the direction angle. This is the angle starting from 0 degree here. And then in order to find this, you can just open up tangent theta. So tangent theta is opposite over adjacent B over A. So let's rearrange. This is inverse tangent modulus B over A. So this is the formula for direction angle. However, you may realize here that I put this as theta bar because this is just a reference angle. Later on, our true angle, direction angle, will depend on the quadrant of the vector. Now let's see the horizontal component and also the vertical component. For horizontal component, let's open up cos theta. So cos theta is A over magnitude V. So let's rearrange. A is equal to magnitude V cos theta. Let's see for B. Okay, to find B, let's find out what is sine theta. So sine theta is opposite over hypotenuse. So B over magnitude V. So let's rearrange. B now is equal to magnitude V sine theta. So now we got our horizontal component and also vertical component. So let us rearrange, substitute it into our vector AI plus BJ. So A is magnitude V cos theta I plus BJ. So B is magnitude V sine theta J. Since you know that this is common term, let's just take out, factorize. Therefore, our V now is equal to magnitude V in bracket cos theta I plus sine theta T. So this is another way to write your position vector in terms of its magnitude and also direction. Since we know this equation here, therefore, let us try to find out this vector V. So given this V in terms of AI plus BJ, which is minus 4i plus 4 sec 3j, the question is, find magnitude and the direction angle of V. So first of all, let us find the magnitude. So magnitude, the formula is square root of A squared plus B squared. So our A is minus 4, our B is 4 sec 3, square it, add them up, and then square root, this is equal to 8. Now, to find direction angle, first of all, we need to touch the graph. Your A is negative value, your B is positive value. So now you are in quadrant 2. So be careful, this is your reference angle. Okay, so in order to find your true angle, this is 180 degree minus your reference angle. So let's fill in the formula for reference angle, inverse tangent modulus B over A. So if you solve this, this is equal to 60 degree. So let's find the true angle, 180 degree minus 60 degree, this is 120 degree. So now let us substitute the formula. V is equal to magnitude V in bracket cos theta I plus sine theta J. So let us fill in the value of magnitude and also theta. Therefore, your final answer is 8 in bracket cos 120 degree I plus sine 120 degree G. So this is your answer for V in terms of the magnitude and direction angle.